Hello everyone, my name is Max Kashnitsky. I'm part of Team 16 Commuter Solutions, here today to present the Auto Watering Plant System Flex with an emphasis on its later product development stages. So at its core, the AWPS Flex is designed for plant owners. This is a diagram of our mission statement. The device was originally made to assist college kids in routine watering of their plants when they are away from home and unable to water their plants themselves. We quickly realized that there's a secondary market for any people that have busy schedules, who are traveling and find it difficult to water their plants while they're home. There's also a portion of people who may be stationed at home but simply do not want to have to remember or have the responsibility of watering their plants. The primary stakeholders for this product are the users and the customers, and also the AWPS stakeholders. So this is a table we developed after conducting customer interviews. It states the customer statement as they said it, and also our interpreted need and whether it's a primary or secondary need for our product. The first need that we identified is that this product needs to be customizable to fit different plant needs. Different people have different plants and different styles of care, and this product therefore needs to accommodate all of them. We also identified that this must be affordable for a college student. And because of this need, we developed the goal of making this product affordable enough that people would purchase it without question with their first houseplant. People also expressed a need for reliability, and this is why we placed a heavy emphasis on our FMEA analysis, which you'll see later. Next, the design must be compact and sleek and fit in with someone's garden rather than sticking out like a sore thumb. It also needs to be easy to use with a clear path to create a multi-plant system in case people want to expand their garden capabilities. So to address these needs, we came up with a variety of effective designs. We used a gallery method approach to convey all of our ideas. You can see a couple of the designs here, for example, the Ultimate Expansion Package or the Ultimate Autonomy Package. We identified critical sub-functions and came up with different combinations of them. We ultimately decided on the second option you can see here, which has a computer input, which we decided was the simplest, cheapest, and most customizable, and an onboard SD card with pump. However, based on our cost analysis, we ultimately exchanged the onboard SD card for a computer-logged data logging system. So this is our FMEA analysis, which played a huge role in refining our final design. First, we identified the failure of the water pump running out of water, which is ultimately a result of an inadequate reservoir selection on the user's part. So to address this, we created an output within the Arduino program that specifies an ideal reservoir size depending on the length of time the plant is to be watered and also how often it's watered. Because of this, the user will be able to quickly identify an adequate reservoir to use with our product that will prevent the pump from running out of water. Second, we identified the most severe failure, as you can see by its RPN number, to be the Arduino control board short-circuiting due to water contact. This is inherent with any system that combines electronics and water, and to address this, we decided to coat the Arduino PCB with a waterproofing layer or build a waterproof enclosure for it, which you'll see later. The next failure mode was a leak in the tubing, which could be because of inadequate setup, for example, not placing the output hose over the plant soil. This could end up with water getting where it's not meant to be and causing water damage. To address this, we will include a detailed guide explaining proper tubing setup to avoid this sort of error with the final product. And finally, we identified that the user could have issues converting their normal manual watering schedule to the Arduino control system. Because of this, we included information in the program that does the necessary calculations to convert a manual watering schedule to an automated watering schedule. It's important to note that many of these issues are a result of the consumer, but we included this information and addressed them to minimize customer dissatisfaction with the product. So the final prototype met all of our critical needs. As you can see from this photo, you can barely tell that our product is positioned on it, and you can see that the plant still carries out its purpose to be aesthetically pleasing. So now to run through how the product sets up, you can see first you plug it in, make sure that the green indicator light comes on, then you position the output hose over the plant soil, and then position the input hose into this user-supplied reservoir. And you can see our product successfully waters the plant according to the user input schedule. So the production CAD designs that we created improved on the final prototype. As you can see from here, one of our primary goals in the final production design was to create significant separation between the electronics, which you can see the Arduino board in the blue, and the pump, which you can see on the right. Further, we included hosing coming out of the pipe and out of the case, so the customer does not have to make any tubing connections inside the case and therefore place the Arduino board at risk. And it's important to note this is how it will come assembled from the factory. So the custom case is a critical part of our design, and we are prepared to work with manufacturers to make it a reality. As you can see, we included standoff posts in the design that suspend the Arduino board above the bottom of the case, meaning that it won't get damaged by water if water were to pool. Further, we have an open face design which allows the user to access the Arduino board, and should there be a buildup of water, easy draining. You can see that we have a fully dimensioned sketches here ready to provide to manufacturers to ensure that our case fits within specification. The color of the case was selected to be a transparent color so that customer can see if there's any sort of leak, condensation, or anything abnormal going on inside. However, it was tinted in orangish terracotta color to match well in gardens and not stand out. Pending success with our original product, we are ready to expand. One of the key difficulties we had and challenges that we think we overcame was balancing the technical ability of our project with customer ease of use. This was apparent to us from when we first developed our quality function deployment matrix, which we presented in the DP1 presentation. You can see that the need of independent customizable items was ranked the highest. However, it's closely followed by price, physical setup time, and programming time. These inherently conflict each other in our designs, and this conflict was also apparent when we conducted cultural analysis for different parts of the world. We realized that not everyone everywhere wants our product to completely take over plant care, and some people may want it to play more of a supportive role rather than a takeover role. Because of this, we propose that we continue base model production, but also create a pro model or upgrade kit that allows the user to implement a whole variety of sensors, multiple pumps, and whatever they may need to satisfy their gardening needs. So with that, I'd like to wrap up the presentation and ask if anyone has questions and thank them for their time. Thank you.